Hey YouTube, Never Ending Student here. It is Friday, March 21st, and I'm here to take a look at some multimeter probes. Specifically, I recently got a couple sets by Mechanic. First off, this is not like a paid or compensated review. Mechanic didn't contact me. I bought these with my own money. This was just me being curious as to, are these any good? So, I've been seeing the quality of certain things coming out of certain Chinese brands going up and getting actually pretty decent. Like we have my Rigel scope over here that I like quite a bit. It's only a, 125 meg scope. You can hack it and get 250 out of it, but it's nothing like it's a multi-gig scope. That technology has been around for decades, but it has a lot of nice features and it's small. Not about that though. So these, I was able to get them pretty cheaply, and I think like sub $8, maybe sub $9, something like that. And I really wanted to know, how do they stand up against some of the leaders? So right here, I don't offhand know what exact model this is. It is Pomona. I believe it came with one of my meters. It's one of the nice ones that have little protectors. It's meant for, detailed electronics work. It has that nice super sharp needle tip. They're not gold flashed. They are steel alloy for strength. And Pomona is a very well-known brand. These are quite good. It's been, up till a couple months ago, it was what I used on my main meter. More recently, I got these. And one sec, I will show you what that is. I actually bought a couple of them. These are Probemasters. The 8017S model, 48 inches. And they are widely regarded as among the best, if not the best, multimeter leads made in the context of bench electronics work, not for field use, because they're definitely not the durable kind of thing you would want in the field. I use my Fluke twist lock TL 175s for those. But they are gold flashed. They are really soft and flexible. They're just pleasant to work with. They have, I believe they're like gold flashed tellurium copper, or at least gold flashed one of the preferred alloys for this purpose. The tip is quite sharp. They have threading on there for attachments, so you don't have any kind of friction slide over situation where it would, abrade the surface of the lead. And I've enjoyed using these a great deal. So, only time will tell how well these stand up to use. So it's not really something we can know right now, but what we can measure is, how good is the material, the tips, and the overall lead resistance. That we can check. Now, while the 34465A is a wonderful meter, it is only specified, and I'll show you, its lowest resistance range is the 100 ohm range. Now, it doesn't mean you can't get readings below 100 ohms or below 1 ohm. You can, but the accuracy specifications when you go down that far leave such to be desired. even in 4-wire mode. So, I'll give you an example. We're in ohms here. This will be in 2-wire mode, and for this specific use case, 2-wire is fine. Now, we're trying to measure milliohms, so why would 2-wire be fine? The reason for that is 4-wire resistance measurement technique is meant to be a technique that eliminates the resistance of the length of lead you are using to measure what's at the end. But in this case, we are effectively wanting to measure directly from terminal to terminal, and we are measuring the lead being used for that by just putting in one end of the lead, only using one. It won't work if you use two, because then you're measuring the quality of the connection when you touch them together, and it's questionable. And then we take this, put it in there, and let's see. So I tried pressing down. Now this is just its own weight holding it. That's more stable. And what we're getting from that is it's telling us we have 38.5 milliohms for the total lead resistance of this lead. The only thing that is questionable is the contact quality of this connection right here. So I'll try futzing with it a little bit and see if we get any lower. This is me holding a little bit of pressure. That's not really getting better. I'm trying to hold it flat now. That's better. This is me trying to hold the length of the probe lead flat to get more contact surface area. And we're seeing there 24 milliohms. 24.x milliohms. So let's say that the best reading we're getting with this on here is about 24.5 milliohms. Now let's take it over to the Hioki. This is the 3540 milliohm tester. It's a 4-wire, specifically milliohm meter. It's for low resistance measurements, like when you're measuring how much resistance do you have in a motor coil winding and such. So, we'll show it is properly showing 0 ohms when shorted out and left untouched. So go ahead and connect that. And there we go. 23.9 milliohms. So this was not bad. The reliability of our connection right there was questionable, but the overall reading was not terribly inaccurate. If you were to call it by ppms, it was pretty bad, but in terms of just percentage of value, that wasn't bad at all. So I'm going to call this the definitive one and say 23.9 milliohms for the Probemaster lead. That is the gold flashed, basically considered best for bench electronics work, at least by many. Now, next up is my Probemaster. Pomona. Let's try this one first. So we want to try to get the flat of the metal on it. Oops, sorry. Right about there. Alright, so I just rubbed it against the metal a little bit to get a better connection. And the lowest I'm seeing it touch on is around 60 milliohms. If I let it hang, I don't know if it'll hold, but we can try. then it's not so great. It's definitely a bad connection because we're seeing like 170 milliohms where we were getting around 60 before. Yeah. So call it best reading we got here with a not a great connection, around 60 milliohms. So now let's try it on the Hioki. And this is not gold flashed on either the probe end or the connector. So by 4-wire measurement with solid clipped-on contact, we're seeing 29.8 to 29.9 milliohms. So it's actually pretty similar to that. Although obviously with gold flashed connections, it's a lot easier to establish a high quality, low resistance connection to what you're touching with the probe. So actually going back and forth between these two is a good indicator of not just what's the resistance of the whole lead, but what kind of quality connection do you get off of that probe tip. So now we have the Mechanic P40 and RP15. The P40 shows as 0.2 millimeter needles. The RP15 shows as 0.1 millimeter needles. And it appears that it may be gold flashed. So we'll see. So let's try the steel ones first, because I'm hoping to see better performance out of this if it is actually gold flashing. I think this was $2 more than this one. Okay, so they're not particularly long. So probe tip to connector tip, we're looking at about 120 millimeters, or right around 47 inches approximate. All right. I guess I was kind of getting a deceptive feel because I was feeling from the bottom of here to the bottom of here. And if you take out that much length, it'll be shorter. So yeah, tip to tip, just shy of 48 inches. So equivalent of the Probemaster length. So the material does feel like silicone, or at least something analogous of it. It has that kind of semi-springy wet noodle feel. No stickiness or tackiness. Let's see. Looks like we have some kind of rubber or TPU overmold right here. I can see it slides up, but it doesn't look like this pops off. So hard plastic here, a little bit soft surface feel hard plastic, and then you have kind of a knurled grip here with, yeah, it feels more TPU-ish. That was on there fairly snugly. It's pretty sharp. Looks like the end has a quad split pattern. Alright, let's see what we get. Now keep in mind, one unfair comparison is that these are literally fresh out of the box, never used before, so there's been no chance for an oxide layer to develop. So I'm trying to get the flat onto the flat, or flat on flat, and 53. I saw it touch on 53 milliohms. If I let it rest, about 107. Now let's see what the Hioki says. Okay, so 38.7 milliohms. So we do have, well, fluctuating at 38.6. So we do have more resistance using solid connections with a 4-wire lead, fresh out of the box, than not just our Gold Flash Pomonas, or sorry, Probemasters, but also the steel Pomonas had near equivalent resistance to the Probemaster. And this is about 9.5 to 10 milliohms more. Not the end of the world, but not as good. Now, that was the steel one. I'm not sure if the other one is actually gold flashed or if it just has the appearance of it and it's some like gold colored copper based alloy. But let us take a look. So the next up is the RP15. Oh, it's starting off better already. Instead of just the leads coming out, it's in its own bag. So that's a little bit more attention to detail. A little bit more care taken. So it looks like they include the needles in one of the same cartridge style holders that the tiniest of soldering cartridges come in. And there's nothing attached, or no probe tips attached. It's really minor and hard to tell, but I think this is higher quality. It feels more slippery, smooth silicone. Okay, this specifically says on it, probably can't make out that, but it says silicone rubber. I wonder what this says. This does also say silicone rubber. Foxtrot 135538 and 3239. This one is 18 gauge and this one is 20 gauge. Other than that, it looks like all the markings are the same. 200 degrees, 3 kilovolt, FT1. All right. So yeah, this is, at least by the markings, the same wire except 18 gauge. Or, sorry, no. This should be 20? Okay, sorry. Yeah, I'm reversing that in my head. 18 gauge. This feels thicker. What the hell? Yeah, this says 20 gauge. And this says 18 gauge, but that's thicker, so I don't know what's going on. And with a lot of products out of China, it's kind of up in the air as to how much you can trust anything about it. It's more, you got to verify for yourself, or pay attention to which companies have acted in a reputable manner and stayed consistently reputable. But a lot of Chinese products can be kind of the Wild West of, you know, buyer beware and verify what you get. Okay, so definitely no gold flashing on the contact. In here, I see the same dull steel color with the quad split design. And I see no gold coloration on the threading or surface there. So it's just this. So I'm going to take the thicker probe. And I'm just doing this finger tight. I don't want to like grab onto this with pliers to try to tighten it down. So let's get this probe tip off. So yeah, it might be gold flashed. I'd have to have some kind of chemical analysis to know for sure. But there's of course any number of alloys you can put on something, make something of, or flash on top of, or, you know, electrochemically plate over to make something look gold. So that doesn't really tell us much. No. Let's start here. Same as our same test methodology. That's much improved. That's way better. So we're getting 16 milliohms at the best one I got. I'm trying to flatten it out. That's actually making it worse. Letting it rest. Going down, let's see if it'll settle. .43 milliohms, approximate. A little bit of fluctuation. I saw it go to 19 at one point. I'm going to see if I can do that again. So right now, I'm pushing at an angle and then rotating a little bit. So I got down to 23. Now let's ask the Hioki. And we get 28.7. I didn't write this down and my memory is like not the best, so I'm trying to remember. So 28.7 there. It's not bad. I want to go back to the Probemaster Gold Flash probed. I want to double check what that was. So 24.0 to 24.1. Okay. So these are not bad. Not bad at all. Now these Probemasters, here is what really matters to keep in mind in this comparison. These Probemasters, typically you'll find them for, what, around $40? One sec, I'm going to check. eBay. Probemaster 8017S. All right, so the going price that you can definitely get it at is $41. I believe I got mine for fairly less than that. Yeah, that's the only one there right now. What if it's just 8017? All right, one sec. What did I buy them for? Because I got a good deal. Scroll, scroll, scroll. Lots of eBay history. Further. Okay, so I got mine from Calrite Instruments. I bought two of them for like just about $61 total. Alright, so I got them at a price before shipping. Well, no, you gotta factor in shipping. I got them for 30 bucks a piece. For two of them. And I think part of that was shipping didn't increase or didn't increase by much for ordering more. So figure if you just bought one, it would have been around $33. Now, these, I'm going to double check to see what they're actually going for right now. Mechanic RP15. AliExpress. Okay, so those right now, for choice selections, choice is there, you get free shipping if you buy more than 10 bucks of stuff. $7.52, $6.14. They're on sale right now, but AliExpress regularly has sales, so these are fair prices to consider. So yeah, call it just over $6. That, when you take price into consideration for the context, and understand that we don't have longevity information, we don't know how well these hold up over time, but around, what, 30-something dollars versus $6. 24-ish milliohms versus 28-ish milliohms. That's pretty damn good. When you take into account the price that you pay for what you get, yeah. Now, is this the thinner tip or the thicker tip? This is the thicker tip. And I will mention, the tip is already a teeny bit bent. So how well this will hold up over time, I don't know how much faith I have in that. But it does come with one set of replacement tips. Let's take a look at the thinner one. Now, for some context, really fine probe tips are good to have. And this one is, okay. So yeah, we have one that goes down a completely gradual slope and one that has 2 changes in profile. That's this one. So this one doesn't appear to have any bends in it because it has a more gradual, or it has a more steep taper. It's the same kind of idea of different grinds on a knife edge. Like the more shallow you make the grind, the finer tip you have at the end, but also the weaker mechanically it is. Whereas if you have the blade straight and then at the very edge you have a more heavy angle, then you can never get as sharp, but it will be much more durable because you don't have a lawn thin amount of metal at the end that's going to more easily bend, chip, or break. So these are actually going to be the stronger ones. And just for the heck of it, let's redo our measurements with this other tip. So this is the probably less fragile tip. I think the best I saw there was 29 milliohms. Let's let it rest there. That's doing very well at rest contact at 27 milliohms. And now let's check the Hioki with this other tip. And I'm trying to keep it consistent by having the clips close to the base, though not on the knurled portion, because I don't want to get wonky with what kind of contact quality I'll get. I want consistency. Not all that much difference. 28.0 milliohms. So yeah. Yeah, it's coming apart. Also, Chinese leads. But I'm kind of okay using these as consumable items for like, I think $8 to $10 versus getting like made in Germany ones or such for, I don't know, $200. Or made in Japan. Kelvin clips, the market on Kelvin clips is just weird. But, yeah. It doesn't tell us longevity. It doesn't tell us how well this will hold up. And I'm already going to call it on these like super tapered needles, I mean, that has come new, already bent at the tip. And it feels like the tip is, like the very end of the tip, I think it's broken off. But this one, with the more sharply angled edge, so it's more mechanically strong. If you're doing electronics bench work, which is what this would be purposed for, and you're not abusing it, this is a good deal. The other one, the resistance on there was nowhere like comparable to even the steel Pomonas. But this, the RP15, this might be worth your money, especially considering how little of it costs, and you get nearly the same resistance performance as this. Now, there's one other test we should do, and that's the continuity responsiveness test. And let's start off with the two strongest contenders. So, continuity, gold flash or Probemasters, I'm trying to generate the smallest time interval contact. Let's try this. Yeah, I don't think I can make it less than that. Alright, so even at the smallest interval of contact that I can generate myself, without like making some timing rig and electromechanically reliably making something that just snap touches it, it's triggering every time. Next up, yeah, let's just do them all. Let's get consistency and do the same tests on all of our contenders here. So now we have the steel Pomonas. I've already seen that we can generate poor enough or short enough touch that this did not beep, did not register. Yeah, right now I'm trying to keep it brief and also as light contact as possible, and we are seeing it not detect. Alright, so intermittent results when you're intentionally trying to make the minimum contact and the shortest contact. With the steel Pomonas, we do see continuity not register at times. Whereas with the gold-plated Probemasters, which are gold-plated not just on the probe ends, but also on the connector ends, or gold-flashed, not necessarily plated, we saw consistently effective results. Next up, we have the Mechanic RP40s. That is the all steel. we're already seeing that it's able to not trigger. We had one contact that was hitting this, and that didn't count. That was the one before the last one. So in terms of surface conductivity and surface sensitivity with this material and the connection there, on continuity test for trying to be as challenging as possible on the lead, we are seeing this perform the most poorly of everything we've tried so far. So now, try not to stab myself. Now we'll try the RP15s with the possibly gold flashed, and with the milliohm resistance reading we got, I'm more inclined to believe that it does have some gold flashing. How thick that is in terms of like nanometers, micrometers, I don't really have any way to tell. We'd need someone to tear these down with precision measurement equipment, and it's not something I have access to. But given we saw, like, I think it was 28 milliohms, I am inclined to believe that this has some at least minimal gold alloy flashing on the surface. Let's untangle this. All right. Okay, just to be clear, there were a few times that we had misses where it just went by it. Every time that this has made metal-on-metal contact, without fail, it has beeped. So yeah, I'm going to say that that is a little bit of gold flashing. And these are not bad. The RP40s, oh, sorry. So the RP40s with steel tips are not high performers. They are probably going to be more durable because they have thicker needles and they are all steel, and there's no surface flashing to get rubbed off. And that kind of thing, especially they're communicating it to you because they give you replacement needles. Surface flashing like that, especially if it's been economized, is going to be a consumable item. It might last many years, it might last many months. It really depends on too many factors. How often you use it, how hard you press, do you rub against something to try to get through an oxide layer on your solder, that kind of stuff. But for like $6, the ones with steel, meh. But the mechanic RP15s with the replaceable needles and the gold flashing for $6, I'd recommend these. Meh on the P40s. But the RP15s, I'm going to say that these are probably worth your money. Cool. And again, I bought these with my own money. I haven't been solicited for my opinion on this. This is not a review that has been compensated in any way. No money, no free product, no communication with mechanic. I was just curious about these. All right. See ya.